Now we're going to look at summarizing the data, and here are some of the notational and conventions that we need to be familiar with. So we start with the random variable and observations. Random variable is a variable whose value is determined by chance or using some probability. So in other words, a random variable is one whose possible values are known ahead of time, but what the actual value will be in a particular iteration is unknown ahead of time, but we can associate some probabilities with it. For example, if you want to look at what will be the daily sales next, like tomorrow, and we can pretty much say based on our previous observations, say retail store, maybe $10,000 to say $50,000. Okay, it will be anywhere in between those two limits. Yeah, but what will it be exactly tomorrow? Okay. Well, we cannot predict that ahead of time with 100% certainty. You can say, okay, well, it may follow probability, normal probability distribution or discrete distribution. The actual observation is dependent upon some probability, but the random variable, the possible values are known ahead of time. So variables and parameters. Okay, here we are talking about population and sample. So a population, for example, is a student population at UTC. And if you're looking at GPA of all the students, then what is the average GPA of all the students in UTC? So that will be a parameter. So GPA is a variable. Okay, you can also define another variable, say age of the students. And what is the mean age of the students? That will be a parameter. So variables and parameters. And probability distribution is the probability distribution associated with a random variable. So these are the notational conventions. And we look at several measures of the measure of location, okay, that is average, arithmetic mean, or median, or some order statistics like percentiles and quartiles. And then measures of variation, okay, we have range, mean absolute deviation, variance, standard deviation. And the assessing variability is we can compute a z-score, and z-score is a given observation is how many standard deviations is it away from the mean. So you take the actual value minus average value, so it can be either positive or negative. So that's the total magnitude of the difference, y minus y bar. And then you divide by the standard deviation, it tells us how many standard deviations a particular observation is away from the mean value. So these are some of the measures that we will be looking at. Let's look at examples in Excel. Okay, let's look at this data where we have data, a time series data for the last 7 weeks, and what is the sales in thousands for those 7 weeks. And if you want the arithmetic mean, all we have to do is to sum these numbers and divide by 7. So that will give us the arithmetic mean. Or we can use in Excel, we can use the average function of that range. So that will give us the average sales per week. Now median is the midpoint when you arrange the values from smallest to the largest. So if you take this set of data and sort it going from 8 to 16, okay, in that order, the midpoint. Okay. If the number of observations is odd, then you'll have a specific midpoint. Like for example, if you have 3 observations, 2 is the midpoint. If you have 5 observations, 3 is the midpoint, and so on. So we can select that particular midpoint value as your median. But if you have even number of observations, so for example, if you have 4, so you have 2 and 2, there is no value in between. So you take the 2 values that is closest to the center. So here it will be the second and the third, and average those 2. In Excel, we have median function. So we can just take that and calculate the median. So here so happens that the median and the sample mean are one and the same. Okay, need not be. Now measures of variation. So we have minimum. Okay, we can use the Excel function min and Excel function max. All right. So these two functions give us the minimum value and the maximum value. And the first measure of variation is the range. Range is maximum minus minimum. What is the width of the data going from the smallest to the largest data? So that's your range. We can also compute mean absolute deviation, variance, and standard deviation. So if you take each y value, okay, and subtract from it the arithmetic mean. Okay, now make that absolute reference by pressing the F4 key. So you get the deviation always from B16. Okay, so now if you copy that to the rest of the cells, then you get the deviations. Now the underline is gone. So now let's put the border, the bottom border back, the same one like the others. Okay, now if you take the absolute value, and Excel has a function called ABS, so that will take the absolute value, copy that, okay, and once again put the bottom arrow back. Now these are the deviations. If you sum the deviations, the positive and the negative deviations will cancel each other out perfectly, and you will end up always with a 0. So to measure the variability in the data, you have to make sure that the positives and the negatives don't cancel each other out. And one way of doing that is to take the absolute value and then average that. So that is our mean absolute deviation. So if you make the average, if you compute the average of the absolute deviations, you get MAD. Okay. Now whereas if you want, instead of taking the absolute deviation, if you square those deviations, that also will take away the negative values, will make them all positive. Okay, and make sure you put the border back. Okay, now let's find the sum. Now there is, you can average this, because for variance of a sample, so if this was a population, you can simply take the average of all this. But since this is a sample, okay, so you have to take that and divide by n minus 1. Okay, n minus 1 is, let's do a count of this minus 1, and make sure that the brackets are properly placed. So that will give us the variance. The denominator is n minus 1. And standard deviation is simply the square root of, and square root function is SQRT of that. Okay, so that will give us the standard deviation of the y values. But it so happens that in Excel we have functions for that. So we have what is called VAR, and then there is .p for population variance, which actually takes the deviations, sums them, and divide by n. Okay, or you can use VAR.s, which will be the denominator is n minus 1. So this is the sample variance. So you provide the y values. Now that will give us the variance, and you can take a square root of that, or you can use the standard deviation .s function. That will give us the standard deviation, which is same as these two values. Let's now calculate the z values. So we take the difference, y minus y bar, and divide by the standard deviation, which is over here. And standard deviation should be absolute referenced. So this means the number 15, the first observation, week 1, is about little less than 1 standard deviation above the arithmetic mean. And similarly here you have the rest of the values of z, This here means week 6 is 1.29 standard deviations below the mean.